What's up, guys? How you doing? You ready for some math? So today we're talking about rational numbers. This should be a pretty short section. We're just going to talk about a rational number and what it is. So a rational number is any number that can be written in this form a over b, where a and b are integers. We talked about integers in the whole last chapter. Integers are basically positive and negative whole numbers. So if we can make a fraction out of two whole numbers, two integers I should say, because they could be negative 2, then it's a rational number. So all these right here, these are all rational numbers. And we're going to look, first of all, we're on page 177 in your book. So if you want to turn there, all these numbers are on this page too. Negative 15. I can write it like this, can't I? Negative 15 is the same as negative 15 over 1, isn't it? We can put any number over 1 and it's the same number because anything divided by 1 is itself. So negative 15 is rational because we can write it as negative 15 over 1. We can write it in this form a over b. Negative 15 is an integer, 1 is an integer. Negative 0.8 is also a rational number because we could write that as negative 8 over 10. Negative 1/8 is already in this form, a over b. 28% is the same as 28 over 100, so since that can be written as a ratio of integers, that is also a rational number. Almost all the numbers that we deal with on a regular basis are, in fact, rational numbers. Integers are rational numbers. Fractions, as long as the top and bottom are both rational, or both integers, are rational numbers. Decimals are rational numbers as long as they repeat or end. And we're going to spend some time in this section looking at the different forms of rational numbers. So we're going to look at rational numbers written as decimals first of all. Any fraction can be expressed as a decimal, and this is on page 178. Any fraction can be expressed as a decimal by dividing the numerator by the denominator. The decimal form of a rational number is called a repeating decimal. Repeating decimals can be represented using bar notation. In bar notation, a bar is drawn over the digits that repeat. Now, I'm not a big fan of the way the book says that the decimal form of a rational number is called a repeating decimal. Not every decimal is necessarily a repeating decimal, so we'll kind of talk about that. But I think you guys have done this before. Negative 0.44444 is, what is this? What do we do here? Oh, look at, oh, that's kind of cool. Look at that. Check that out. Negative 0.444, instead of writing it as 4444 dot 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 or 4343 dot dot dot, we can, oh, look at this. Ready? Whoop, there it's gone. Now you see it, now you don't. Now you see it, now you don't. Now you see it. Okay, so negative 0.444 is negative 0.4 with a line over it. So the digit that repeats, if you draw a little line over it, that means repeating. So we could say this is negative 0.4 repeating. And here, 43 repeats. It's 4343 4343, but instead of writing a whole bunch of 43s, we can just write 43 with a line over it. So sometimes only one digit repeats, sometimes there's going to be more than one digit that repeats. So if we wanted to fill in 0.1 repeating, and this is on page 178, so you can actually fill in these boxes on 178. 0.11111 would be 0.1 with a line over it, or 0.1 repeating. Now be careful here, look at all these, and look at the difference. 0.611111, it's only the one that repeats. So we are going to use this one, versus this, 6161 is what repeats. So here, the 61 has the line over it. So you only draw the line over the part that repeats in a decimal. Alright, I had to pause that for a second. Now here, this is 0.616000000. So 0 is the only thing that repeats. And that's why they're calling all these repeating decimals. But most books and most texts would not call this repeating. The 0 repeating, any number you could add zeros at the end. and have that go on forever. The number 5, you could write 5.00000. That's not really a repeating decimal. So if it's just the 0 that repeats, no one would really ever do this. So I don't know why your book does that. Here, now this one's kind of tricky. It's 161. Can you see it's 161, 161? So the 161, this one has 3 digits that repeat. And let's just check. Good to know that I know what I'm talking about. Now, again, I don't like the way this book says it. Every decimal is a repeating decimal. Decimals with a repeating digit of 0 are called terminating decimals. So technically, almost every other text you're going to see and every other mathematician you're going to see is going to call them terminating decimals. So not if it's anything other than 0 that repeats, then it's a repeating decimal. Otherwise, it's a terminating decimal. So we would never really write this. We're going to write 0.25. So if it's the 0 that is what's repeating, then we call that a terminating decimal. Terminate, think about, I don't know, you guys probably don't even know the terminator, but terminate means to end. So terminating decimals end eventually. So what you're going to be doing in this section is writing fractions as decimals and then determining if it's a terminating decimal or not. So all you have to do to write a fraction as a decimal is remember what the bar in between a fraction is, in the middle of the fraction is. What symbol is that? Yeah, it means 1/40 or 1 over 40, but it's also a division symbol. So the way we change a decimal to a fraction to a decimal is taking the numerator 1 and dividing it by 40. So obviously 40 doesn't go into 1, so we're going to have to add a decimal point after the 1 and add some zeros here and perform our long division. Okay, so if you forgot, I will kind of work this out with you really quickly. So if I have 1.00 and a 40 here, then the decimal, we bring it right up over where it is here. And 40 goes into 10 0 times, so we'll have to multiply that. And then the next step is subtract. 40 doesn't go into 10, so now we're going to bring down this 0. 40 goes into 100 twice, so we subtract again. What's happening here? Why is this not writing? Okay, this doesn't want to write. Hopefully you guys can see this. Sorry, I don't know why I'm having such issues with my stylus. 100 minus 80 is 200. You could see it over here. You can't read my writing. And 40 goes into 200 5 times. And when I multiply this, oh my goodness. Why does... This does not want to work for me today for some reason. Okay, so anyway, you can see over here, when we multiply 5 times 40, it's 200. So we get a remainder of 0. So if you end up with a remainder of 0, this is how you know that it's going to be a terminating decimal. So when you divide the top by the bottom and you get no remainder, so you end up with a remainder of 0, then this is just going to have zeros that repeat. Okay, but once you get the 0 that repeats, we can just cut it off here, and this is the same as 0.025. So 1 over 40 is the same as 0.025. So when the remainder is 0, it is going to be a terminating decimal. So it ends with repeating zeros, but really if it, like I said, if you get a remainder of 0, you can stop there. It's a terminating decimal. So again, anytime you want to write a fraction as a decimal, you just take the top number divided by the bottom. -5/6 of this as a decimal. Rational numbers can be positive or negative. So in this case, we're going to divide 5 by 6, but our sign will be negative because it's -5/6. And in this case, when I look at 6 going into 50, that's 8 times. Multiply, subtract, bring down. 6 goes into 20 3 times. Multiply, subtract, bring down. And here, this is going to keep going here. This is going to be a 20. 6 goes into 20 3 times. 3 times 6 is 18. And we keep getting that same remainder. So what's going to happen if I keep doing this is just going to keep being 3 with a remainder of 2. So if that happens, where you keep getting that same remainder over and over again, and this ends up being the same digit, then you know that this is a repeating decimal. It's not a terminating decimal. So we can write this as negative 0.83 or negative 0.8333 or negative 0.83 with the 3, with a bar over the 3, just the 3, because it's only the 3 that repeats. So this one is not terminating. It does not end. And so that's really all we have for this section. Just, what is a rational number? Is it terminating or non-terminating? So basically terminating or repeating are your two options. If it ends with no remainder, or if you keep getting the same remainder over and over and it repeats over and over. And then you should be able to write any fraction as a decimal, and if it is repeating, know where to draw the bar. So that's all we've got for this section. Peace.